All right, here we are. We have NET-200, and we are on week 5, and today is 9/24/14. And we're actually here talking about chapter 4, access. All right, so we started off in the class. I won't go through all the details. I started out and I wrote physical on the board, the physical layer. We talked a little bit about that because that's going to give us our access into the network. Then we mentioned the data link and we reviewed. We mentioned 802.3 for wired, 802.11 wireless, and we know there's other options available. Then I asked what kind of addressing is that, and the students, it's a MAC address, also referred to as a physical address for our devices. So we have some device. Let's say it's a smartphone, maybe it is a laptop or tablet device, or maybe a PC, a hard drive and monitor and all that stuff. All of them need a way, if we're going to share data, they need a way to get into the network. And that's what we're talking about here. Are they wired? Is it wireless? Or are we fiber? Okay? They all have a physical address that's going to uniquely identify each of them. Now, once in the network, okay, we have some protocol that's going to move our information around. So then we talked briefly about transport and network layers. This says path. Trying to find which path to take. We have TCP, IP, it's a protocol. We learned about protocols a little bit in chapter 3. IP address, then I asked them, why is that called a logical address and how is that different than a physical address? And a couple things the students mentioned, it obtains that, usually gets a logical address, and you could have your phone's got a MAC address, but depending on where you are, it could get different logical addresses. If you're at home, right? If you're at home, you're at the coffee shop, you're at NIACC, so it can get logical addresses from any of those. Or if you're just using your own provider, your 4G or whatever, it's going to get an address in order to communicate on the network. And then we reviewed, setting up a session, presenting the data so that you can get in there in your application, your link into your app. All right. Wired, wireless, fiber. And we actually looked at some twisted pair wire. We didn't look at any coax today, but we mentioned that. We talked about sending it through the air or sending it via light. Then we talked about bandwidth. Okay, the idea of how many bits can we send through the medium. A higher bandwidth doesn't mean it's going faster, it just means there's more bits going. It's like water in a pipe. If you make the pipe bigger, you're going to move more water through. That makes sense? Then if the pipe is narrower, even though it's moving. Electricity, it moves a certain speed. Light moves a certain speed. You don't speed up the light or slow it down. So bandwidth, the transfer rate, bits per second, is what we typically use. But it's a transfer. What rate are we transferring data? So you got to be a little careful too, because some people say, well, you got to have lots of speed to get to the internet. Things are, it's too slow to the internet. Well, there's a big difference between this connection, the speed there, and maybe the speed in your LAN. Your LAN, moving things around within your LAN is tremendously faster, typically, than this connection. So let's just say you have Mediacom and you have an extremely good connection. You have 30 million bits per second down, let's say from Mediacom. In your LAN, you probably have them, if you're connected by wire, you have a minimum of 100 million bits per second, or maybe even more. And depending on your wireless in terms, that may be slower. It depends on how you have it. All right. So a big thing here, understand, then the next term, frames encapsulating. We have data, that we're going to send. Okay, the data then is segmented. We can't send, or we don't want to send the data in one big chunk, so we're going to make chunks of data and give them port numbers depending on what protocol we're currently using, what we're doing. Is it email? Is it HTTPS? Is it going to a website? Are we FTP? Are we downloading DNS, getting an IP address, and so forth? So we now have these segments. We turn them into packets, and we assign an IP address. So that's encapsulating. Okay, we now take one of those. It has a port number in there, but we don't care about the port number here, because all we care about is adding the IP addressing, source and destination, and some other stuff. Then when it gets to be a frame, we add, if it's Ethernet, okay, if it's an Ethernet connection in our LAN or wherever, the frame, we add some more information. And what's important, though, the frame will add the preamble, destination MAC, source MAC, and then eventually in there is the data, and that data is everything that's from here. The data link layer that does this doesn't care what's in the data. It doesn't care about the IP addressing or any of that. It just is going to add the framing part, create a frame in order to be able to put the bits on the medium and get them between two links. Data link, getting from this, create a link to get it from here to here, a data link. So from the workstation in our lab to the switch in our lab room. All right. Last thing, we actually talked about a number of things in here. We've got an ISP, we have our connection. I talked about a local area network, a server, and sending data through the network. We talked about, how far can you send, how long can you have a copper wire between two connections. Usually they want to say 90 meters. And then, you have a cable in your rack. So you have a patch cable in the rack, and then you have 90 meters to the wall, let's say, and then from the wall you have a patch cable to your, let's say, PC. Total distance can't be over 100 meters because the signal is moving through wire. Okay, it's different for fiber, different forms of fiber, it's different. Okay, and then we talked about just the fact if one cable is damaged in your scenario here, TCP, if you're trying to get to a website, TCP, it'll keep resending until it gets all the packets. So if the packets are constantly getting damaged because of a bad cable, you will not eliminate the fact that your network is slow until you take care of where that bad cable is. And we'll talk some more about that on Friday. So, chapters 1 through 3, we need to review, and we need to relearn the things we don't quite get yet. So we're working on that. You need to look at your assessments and see if you can figure out what parts you need to go back through. Okay? And so we're going to work on that part of the day on Friday, and then on also on Friday we'll continue on chapter 4. But we won't finish 4 until the following Wednesday. All right, and that's it.